discussed about the Lang chain, right? That's the one of the framework used to develop LLM applications. If you see our workflows, right, there are two types of workflows. Okay, so one is sequential, another one is a graph based or non-sequential. So LangChain is basically used for. Oh, not at streaming. Okay, let me show. Okay. Yeah. Okay. Yeah. So LangChain is basically for sequential flows. So as we discussed, we have two types of flows. One is sequential, another one is graph based or any non-sequential. Okay, so LangGraph is the one, so which is going to be used for that. So before that, let's see what is the limitation or the any problems when using LangChain. Okay, yeah, of course, LangChain is used for developing LLM based workflows. These LangChains are good for following sequential. So it's a chain of flows where one module output is the input for another module. Okay, these kind of things maybe you can go for LangChain. Okay, um, so agents are very good at the following the sequential flow, right? So following in a sense, like going one by one. Okay, but so are they really autonomous? So sequential flows are not really autonomous. Okay, let's say if you have some conditions, let's say basing on some condition, if you want to go to another flow, okay, LangChain may not help on that. Okay, these will not help if you have a condition based decisions. Okay, so that's where comes LangGraph. Okay, this is also an open source framework. This is basically extension of LangChain. Okay, so that's why we are going in a order. So first we are learning LangChain, then we are going to LangGraph. Okay, so LangGraph is obviously open source. So AI agent framework. This is to design, build, deploy, and manage complex AI application flows. Okay, so the complex is the main thing. So LangGraph is a sequential, so it's a single flow. Whereas in LangGraph, you can have multiple modules, multiple systems. We can communicate. Okay, so this LangGraph it provides a set of tools and libraries. Okay, so it enables users to create, run, and optimize LLMs. Okay, so basically it's basically uses a graph based architecture. Okay, so graph based means we'll have a nodes and edges in that. Okay, we'll discuss those things. Of course, this is LangGraph is managed by LangChain. Okay, this is a also very popular framework for building agentic AI applications. Okay, so any questions here? Yeah, this most on a high level understanding of this framework. Okay, let's see the basic components of components and elements of LangGraph. Okay, see if you see here graph, I think everybody knows. So graph is basically it is having a node, edge, and connectivity between those things. Okay, so that's where here you see, if you see the graph, anything you can keep it as a graph. So no, so and the graph contains three things. One is a node, another one is edge, another one is state. Let's see these things. These are very important. If you are not clear, as you ask me, I'll try to explain in detail. Okay, so node is basically that could be anything. Okay, so any unit of work. Okay, so are we basing on some conditional addition. Okay, let's say addition of two numbers that we call as a one node. Okay, so getting a result from external API, that is another node. Okay, those things we can call it as a simple node, any task. Okay, or a node can be any function call, LLM invocation, or tool, maybe that agent can use. Okay, so the node needs to execute and return a result. That is basically one program. We can call it as a program or function or a simple small application we can call it. Okay, that is the thing. So in this workflow, so we have a start and end. Okay, every workflow ends with a END node. So END, that's a capital thing, that is a graph. Okay, node in a graph, which shows the end of the workflow. And you also have a start. Okay, START, start is a thing. If you see these things, maybe you might compare this one with our academics. We used to learn flowchart, right? In flowchart, normally we have a start and end. Between those things, we have a different things. Okay, it's kind of a flowchart. We can compare that one if you want to make it more simpler way. Okay, any questions here? So node is clear. Okay, now let's go to the next thing, state. What is state? Because state is very important in LangGraph. That is what so makes the difference between LangGraph and LangChain. Okay, state is the information which can be passed between the nodes in a whole graph. Basically information passing. So node is basically, that is information passing. Let's say state. So let's say we are at this node, and if you want to go to the next state, next node, basing on the state, so it will pass to the next node. Okay, this is a passing information. For each node, the state values may change. Okay, structure will be same, but values may change. This allows different nodes to understand the context of the execution. See, let's say we are here and the node. Also, the same like how, yeah, let's say you want to go from our home to office. Okay, so let's take that is the source and destination. Let's take a distance between these two nodes is 10 kilometers. Okay, so you started at your home, distance remaining is 10 kilometers, that is your state. Let's say you traveled some 2 kilometers, and let's say that state is middle, M1. Let's take M1 state. At M1 node, the distance between source and destination is obviously 8 kilometers, right? So 2 kilometers were passed, that kind of thing. That is a state. At M1 the state is 8 kilometers, that kind of thing. So here we have a so there are two types of graphs. Okay, one is a basic graph and stateful graph. So so basic graph is basically straightforward, only pass the output of first node to the next node. Okay, so that's the one. Whereas stateful graph, so which be passed between multiple nodes, you can access them at each node. Okay, so mostly we'll go for a stateful graph, because in each node we have a state. Okay, here we have a node is having a different value, and here is another node, here we have a state is having a different value. Any questions here? Okay, so depending on the state values, right, these graphs will change. So majorly we'll go for stateful graphs, because we'll have a lot of conditions, all the stuff. Okay, basic graph is basically similar to LangChain. It's a sequential thing. So okay, let's go to the edge. So edges are used to connect the nodes which are created. Okay, so basically that arrow normally we'll call as a edge in a normal definition of the graph, but here, so edge is basically, it's a connection between the two nodes. Okay, so this is basically, it links the different nodes together and defines a path after a node execution is complete. See see, if you see the statement clearly, See, we are here, we are at this edge. Here, after executing this one, it decides whether it's go to the end of the graph or it will go to the next node. Okay. Okay. So this edge will decide the path which way it should go basing on the state. So an edge can also be used as a conditional check to decide which node to invoke in the next graph. So here there are two types of edges. One is a simple edge and another one is conditional edge. Okay, so conditional edge basing on a condition which flow we need to decide. So that will decide the edge. Okay, it looks simple, but these are the main components of a LangGraph. When you are trying to develop agentic based applications, a LangGraph is going to be key. Okay, it's having a lot of subsystems we need to communicate. So we can subsystem we can call it as a node, and the conditions, right, wherever the conditions we are going to validate, that we'll call as edge, and the data between passing those two things we'll call as a state. Okay, so the state in technical terms you can call it as a data structure or a dictionary, okay, or key value pair, basically JSON object. State we can call it as a JSON objects where we have a values, so those values will change regularly. Okay, so let's take an example at here, source and destination. So you started here, source, distance is 10 kilometers. Okay, state, key is the distance, value is 10 kilometers. When you are here, so let's take so you traveled basing on some condition and we are here, state, distance, key is distance, value could be earlier it's a 10, now it could be 5. Okay, any questions here? Are you getting, or you have any questions, or end is end of the flow, so basically that's a flow thing. So that's a representation. Yeah, no, yeah, no, it's, see, may not be, see, let's take say a scenario, this is a simple example I have given. So this end could be after node, this node also it could be end. Okay, basically we need to specify the flow where it is going to end. So here it's one end and here also we should end. So this kind of a flow like this, initial start here and the edge, so it will go node and it will come here again, edge, it will come here, it will go here, edge, and after some time it may end here. No, we can say that, you can say, but we are not going to write that. So if this one go that, because this LangGraph is providing you that facility, you no need to use if conditions. Okay, so LangGraph is providing one tool called edge. Okay, so that in that edge you can specify conditional based thing. Okay, if the value is this one, you just pass the values and the corresponding path. Okay, so let's say if the distance is 0, go to end. That thing you can say distance 0 end, something like that. Okay, those things we need to specify. I have a sample example I'll show, and then we'll okay, these things basically any workflow should start and should end. This is the thing. So in this case it should start here, because I did not mention, but actually here it should be start. It started. Okay, if you're not specifying this one, for this graph there is no end if you're not specifying this one. Okay, yeah, so either this flow can have multiple ends, right, but those are not at the same time. For a particular flow it should end. Okay, see, if you take this one, it started here, edge, it is going end and is coming here, it is repeating, we don't know how many times it repeated. Okay, after some time it will go to end. Okay, and here so here also if you want you can keep end here. Basically, this kind of a graph, if you remember, I think in our computer science, we used to have this finite automata theory, something like that. You need to have that graphs. Okay, so similar thing. Okay, so basically, simple graph. It starts and it should end. Okay, node, edge, and state. These are the technical terms in LangGraph we are going to use. Any questions here? Okay, so let's compare. Yeah, somebody asking question. Okay, okay. So let's compare LangChain and LangGraph. It's just for understanding purpose. Okay, this is purpose is to build LLM applications. Okay, chains, tools, all the stuff. Okay, so whereas LangGraph is to manage complex workflows. Okay, complex workflows, basically it's having a multiple subsystems. Subsystems could be external systems. Okay, so LangChain could not be external systems. These are within our intranet, within an organization. Okay, so whereas LangGraph may communicate with external systems, cloud, all the stuff. Okay, and the style is obviously linear, reactive chains, whereas for LangGraph it's a graph based. It support loops, okay, retries, memory, see all these things, memory. So LangChain doesn't have a memory. LangGraph will have a memory, short term memory, long term memory, having the history, all the stuff. Okay, so use cases for LangChain are simple chatbot. Okay, so RAG based applications, sorry, that's a typo. So tool usage. So one of the very common popular use case for LangChain is RAG. Okay, so where a LangGraph is basically complex systems. Okay, so agents with memory, it contains all the history, context, all the stuff. Okay, LangChain is stateless or some partially stateful, whereas LangGraph we need to have a stateful because we need to maintain the memory, right? So long term, short term memory. So for that we need to have a state we need to maintain. State will have and that state will pass the information from one node to other node. Okay, so simple example for LangChain is book a restaurant using an API. Okay, that's a simple sequential flow. So whereas LangGraph scenario, so plan a team lunch. So basically checking a budget, team availability, restaurant availability, dates, all the stuff. Okay, it's having a multiple thing. It's not a sequential. Okay, these are the things. Sorry, let's take a demo then. I have a some sample exam. Yeah, we discussed, right. Let me show you that. No, I showed you, right. Demo also I showed. I uploaded the document, 10th mark list, and yeah. So yeah, these things we already discussed. Yeah. Okay. Yeah. So here I told you that there are two. One is simple workflow and conditional based, right? Let's take those things one by one. Okay. So let's take simple. See, one simple use case I have taken from internet only. So the thing is that let's say you want to convert the currency. Okay, so you have a total amount of some USD, and if you want to convert the amount to INR. Okay, let's take the simple flow. Okay, that's a simple flow. Let me run that one. Then I'll explain. Okay, then you'll get that one. I'm going to run a simple flow where it will I created one app. What it will do, Let's see the flow. So we'll have that one. Okay, so it starts here. We'll calculate the total amount in the current or account or something like that. And if you want to convert, you can convert to INR, all the stuff. Okay, this is a sequential flow. Okay, this is one node. It will calculate the current amount, and in the second node, it will convert that amount into INR. Okay, let's say you have some USD account. In USD, you have some $10. So that will calculate, that will, here it will give the $10 amount. And here if you want to convert that USD to INR, so here this node will give the amount in INR after converting into INR. Okay, this is a simple flow. Any questions here? This kind of a graph, right? It started here and it ended here. In between we have two nodes. The state will initially something is here, and it will here the state is having some information, and after that will come here. Here the state will have some information. Okay, so for that, so simple flow. So here, so basically we need to install a LangGraph. The language, the library is LangGraph. Like LangChain, we use LangChain, right? So whereas LangGraph, that's a LangGraph package. We need to install LangGraph. From that LangGraph, we imported start and end. These are we'll call it special nodes. We can import from LangGraph, and the state, right? So we are maintaining a state. That state. We need to have that state graph, all the stuff. Okay, so these are the three things we need to import. And here, so we are talking about state, right? This state is this custom one. You can define anything here. That is all in our control. Okay, structure we need to maintain by ourselves. Okay, the state here, what I am doing, state. Here I am taking three parameters. One is total STD. I used STD for Singapore dollars. Okay, and total amount and total INR. These are the three things I am maintaining in this state. So and at each node we can find these values. Clear? Any doubt between 7 to 10 lines? I'm expecting a question here. What is type def or type dict? Okay, so type dict basically, if you remember, while we are working on a fast API, we used pydantic model. If you remember, yeah. So the type dict is similar to pydantic model. Basically, it will validate data type. That's it. Okay. So here, so for that we are using a type dict. It's a more like a pydantic. Pydantic is saying more features that is not required here. That's why we are using type dict. It just validates data type, nothing else. Okay. So that we are state we are defining. So if you remember, if you see here. I don't know how long it will take. So yeah. I need to come out of these things, man. Yeah, here, right? State we need to define. We have three things. First, state. We are defining a state here. This is our state. In this state, we have a total STD, total amount, and total INR. These three things I defined. Okay. So, and after defining states, we need to define nodes. Okay, so those nodes are basically, if you see the graph, we have in calculate total and convert into INR, right? These are two nodes I am taking. So let's calculate the total. So to calculate the total, so we need to have a state, right? We are passing that state as an argument. We have a state here. From that state, we have three fields. We can access total SGD or value, and it's a kind of interest rate I am calculating. So now the total amount is, because I got some interest, that's why 0.9. Okay, so now the total is changed to something else. Okay, it's a simple logic, nothing else. This is a simple logic, you can give anything here. And like that, convert to INR, another node, convert to INR. I am taking the state. In the state I have a total amount, actually it should be total SCD, or amount is anything is fine, and total amount multiplied by 65 rupees or 65 or 70, whatever it is, and now we got a total INR. So now I have a two nodes, I have a state. So now we need to make a connection between these two, that is basically edge, right? And any questions here, are you following? Okay, so basically first we need to define a state, and then we need to define edge, nodes. Then we need to make connection between those nodes using state. For that, first we need to create a state graph that we imported from LangGraph. We are passing the state. So now we have a graph. For that graph, we need to assign a nodes. Add node. Okay, so add node. What is a node? So calculate total is a function for that node. The node name is calculate total node. You can give anything here. Okay, this is a node name and the node functionality. This is also node name and the node functionality. Now we created a graph with the nodes, and we did not added edges. So here we need to add edges. So edge, where it will start. So starting, edge start, and that will connect to the calculate node. Okay, and calculate another edge, calculate node to convert to INR, another node, there is a connection. And next one is convert to INR to end. This is the thing. These things we are making. Any questions here? It's a simple, right? We just, if you see the diagram, that's why we need to visualize everything. We need to keep on the paper. Same thing here, we need to draw those things. Okay, after adding these nodes, we need to compile it. So saying to the library, so these are the edges, these are the nodes, this is state. So you build that. Okay, so that one we are compiling. That compiling will give the graph here. So now it's virtually available. Okay, so for the execution we need to invoke that. Okay, invoke that graph with the initial state. What is the initial state? Initial state value. So I am giving a total STD 10. Okay, 10 STD. That's why now the graph will execute that. Let's see the output. So this is a 10, right? So now 10 into multiplied by 65. That is what we will get. So let's, that is a print. We already printed that. See, total STD is 10. Total amount, because of the interest, whatever the value, it got into 10.9, and the total INR is 10.9 multiplied by 65. This is the thing. This is the final state you got. Here we can get the value. Any question? Yeah. Yeah, so simple, but yeah, so because for learning purpose we're doing, actually in reality it's not this these simple nodes, it will have a lot of nodes. Okay, so that's where we need to make initially design the structure, and basing on that we need to follow like this. Okay, let's say if you want to maintain here, so here the conversion, everything is looks simple. Let's say if you want to maintain a short-term, long-term memory, how we are going to maintain, right? Let's say chatbot is having let's take a example of ChatGPT, what you are currently using. Okay, that ChatGPT, so let's say your conversation, right? So in your conversation having a history, let's say from past 1 hour you are asking questions, it's giving a response, you're asking questions, it's giving a response, right? So that thing you want to maintain. Okay, so those kind of thing, LangGraph will help. Yeah, for simple thing, it looks large, but in real time applications, it will help. Okay, is that clear? Yeah, this everything is our own. Okay, still you're not clear because everything we are telling. What is the advantage of say, LangGraph, right? So that's where comes these things. We have automatic decision making and memory management, all this stuff, right? That thing will this LangGraph will help at that level. Okay, we have a multiple modules. How to interact? Let's say first thing. That example, plan a team dinner. Okay, so you just throw ask the prompt of plan a team dinner. So first at the node 1 it takes a plan a dinner as a prompt. Okay, and at that node it will get team members by calling API. Okay, so date, so by calling another API. Okay, so this thing will take care by this LangGraph, but it's not sequential, right? Is that clear? Gauri, is that clear or still okay? Okay, yeah. So see that is a node actually. So basically whether you want to make those two calls as a single node or you want to make those two as two nodes. One is making a call to database and get the result, and another one is making another call to another API. That's what you are asking, right? Huh? Yeah, that we can do. That's what that we can do. That's a node definition. So first we need to make a node definition. So here calculate total is my node definition. So if you want to make another node definition, get all resource, all data from, let's take all data, get data from all sources. Let's make this is the one. Okay, so here you can one thing you can get from DB is 1, get from API is 1, like this you can keep and return consolidates. Okay, like this you can do. Okay, this is another node. Yeah, that is also fine. Yeah, that is also fine. So either that that's the flow, that flow, how you want to make that flow, that you need to decide. Let's say my goal is to get data from all sources. That's the thing. For that, whether you want to make this one is a single node or multiple nodes. Okay, you can make first make a data from DB is one node, next another one is get from API is another node, and you connect them one by one. First DB, next API. What console? What a result, right? Yeah. So this one you are making, right? After getting this DB, this will update in state, right? This is basically state, and here we have another state. The same state will have. Let's say in the DB we have some details, user details. Okay. This one is user details. Maybe this one is having a location details. Something like this. Okay, that is already everything is maintained on state. Okay. Hmm. Yeah, but we can do, but the thing is that that is where comes understanding, Shiva. Okay, we have so many languages, we have so many programming languages. Okay, but why we are going for a specific use case? We are going to Python, specific use case for Java, specific use for some Node.js. It's on depending upon our scenario. Okay, so for LLM based application, this LangGraph will help to design complex systems. Okay, yeah, calculator program you can write in Java, you can write in Python, right? Yeah, but the tools, so this tool LangGraph will help to utilize those things like how to maintain a memory, how to pass the state, okay, how to make the decisions, how to interact with the LLMs. Okay, in that, yeah, without LangGraph also you can do it, but we need to write lot of code. The word boilerplate. Okay, that's a very common code. That is LangGraph is not is providing us. You no need to write that basic code. That's a common for all the things. It is eliminating and providing you all the tools to avoid that. Okay. Yeah. Uh-huh. Okay. Okay. Uh-huh. Yeah, so that we can define how we are going to make that is the question. Let's say if you want to get this, if you want to make it a sequential or dependency or something like that, if the DB is not available, go make a call to API, right? So uh, node is separate, right? Let's say you make a call to database and you got empty results, right? Basically, am I correct? If you get a empty results, then you'll go make a API call. Is that correct? Uh, yeah, that we can define in the state graph, because when you make a DB call on the node, one node is to get the details from DB. Okay, you got the empty results. That state is updated with the empty results. And the edge, right? Edge is taking the decision. If the state is empty, go to another node, get the API result, make a API call. Yeah, that is the next thing. This is a simple one. That's why it's. I'll show you the next one. I'll okay. So let me run that next medium one. Let's say medium. For our understanding purpose, I showed this one. Instead of this thing, we can decide in big complex systems, right? Instead of this one, storing in the database or updating the database, all the stuff. Okay. Yeah, here we compiling will not work. We need to invoke it. That is where we'll start the initiation. Okay. That is the only thing we need to remind. If you see here, start calculate total node, and basing on that I can convert into INR, or I can convert into USD, I can convert into GBP and UK pound. Okay, this is a conditional based flow, and everything after this converting to INR I am ending the flow, or maybe I can go to again total mode, or I can go to convert into USD. That also I can do, but here that scenario is end. After converting USD I am stopping, after converting to GBP I am stopping. Okay, so here calculate total node, right? Here it is making a decision basing on input type or state value. Okay, so here the state is empty, maybe you can make a API call node, you can go here. If it is not empty, maybe come here, like that. Or you can end, if it is not empty, you can end the flow. Clear? Any questions here? This is the graph, this is basically our design. Okay, this is a pictorial view. The similar way you need to make a LangGraph code. So here basically I am finding the total amount, and then converting into INR is one node, converting to USD is another node, converting to GBP is another node. Okay, so these things we are passing at the time of execution. Let's see what is the result here. So currency I am passing INR, that's why see I got a INR result and it stopped. So let's see the code. So what is the one? For drawing the graph I'll explain that later, but first let's see that I made it as a medium actually. Medium code. See, everything is same. So graph will have a start and end nodes, and we need to have a state graph to initiate the graph, and I'm deciding here is a state. So if you compare with the previous one, here the state I'm having different values, total ISD SGD, and total amount and currency types. Okay, this is basically enum values. It is having only 3: USD, GBP and INR. Okay, and calculate the total. So calculate the total and convert into INR is same, convert to USD. So basically thing is that here it's a 65, it's 1.5, and GBP is 1.8. Same logic, because logic we not consider logic here, but we need to see the nodes because we are learning here. Okay, so now we have these nodes, and we need to decide, right? So on whenever, so which node, the flow should go to which node basing on the value. Okay, so for that we need to have another thing called another conditional based state. Okay, that will call as here is a select currency, basically which currency you want to start, whether it's INR, GBP or USD kind of thing. Okay, so now here we have a see 4 nodes that are similar to in the previous example. Create a state graph initially, pass initial state, and add nodes. Calculate a total node name, corresponding functionality, INR, convert to INR, node name, corresponding functionality, convert to USD, node name, corresponding functionality, convert to GBP, node name and corresponding functionality. Okay, until here everything is fine. We define nodes, and when you are making edges, right, if you remember, we have a simple nodes and conditional based node edges. Okay, so that is where here we are add this is a starting node, calculate total until this thing is same. See here, start, next calculate total node, this is a straight line. After calculate total node, we need to change the flow depending upon the condition. That thing here we'll call it as conditional edge. Add conditional edges is the one. Okay, add conditional edges. Here it will decide that. So from node is a calculate total node, and here we have a 2 parameters. One is to get the condition, Okay, one is to get the condition, and the next one is on that condition what is the value node we need to redirect. Let's say select currency. Let's say if you select INR, which node it should go, that is a key value pair. Input is INR, go to INR node, convert to INR node. If it is GBP, go to GBP node. If it is USD, go to USD. This is the one we need to remember. You're getting? Select currency. So basically this is we're passing that thing. So if it is a boolean condition, so we have our two cases, right? True, false. If it is true, true case, functionality. False case, false, functionality. Like that. Are you getting? So see, normally adding edge is basically will take a node and the corresponding node and node, only two things. Whereas conditional case, node, okay, one is a node name, another one is a selection process, and after selecting you will have a result, right? When you are selecting you will get the result. So that possible result, the corresponding mapping, this is a mapping kind of thing. So key value have. And here so this we need to have an AND case, that's why AND is similar to previous one. Okay, so after INR conversion and after converting to USD and after converting GBP, and any questions here? So see, while invoking here, what I am passing, state I am passing. Okay, USD and the target currency is INR. Let's say if I comment this one, I'll run this. Let's run this again. Okay, so here it's the GBP and the total is 18. Any questions here? Are you getting? If you see here, we are not doing any programming related stuff. Okay. Uh-huh. Uh-huh. No. So see the flow graph, see how we are going to complete the goal. Okay, here is the goal. What is your goal? Okay, so if okay. Uh-huh. No, right. Okay. That thing, see, let's say it's a kind of let's say if we already have it, so normally it should go complete the flow. Okay, it should complete the flow basing on the state. Okay, so whether if the state is depending on the value, state value only, if the state is wants to complete the thing, it will complete the flow. Okay, if not, so it will complete within a after that node. That's why that graph is important, where you are going to end that graph. Let's right. Let's say where is that? Where is the graph? Yeah, here. If you see here, this one we started here, end node and completing, continuing. So how many times it is going to complete circle here? We don't know. That completely depends upon state value. Okay, if the state value reaches the end thing, and it will redirect to end. Okay, that we need to understand the system. Okay, let's say get the location. So after getting the location, what you are going to do? Let's say after getting the location, If the location is nearby, stop it. That is one scenario. Uh-huh. Right. Yeah, see, let's say this: get the location, get the location, get the location, get the. See, after get the location, after you got the location, what is the state? Okay, yeah, you got the result. You need to update the state, right? So that, let's take this scenario: get the location, update the distance, get the location, update the distance, get the location, update the distance, get the location, update the distance. Okay, yeah, so yeah, the same stuff. Get the distance, get the location, update the distance. So, and every time after getting a location, updating the distance, it will check whether the, yeah. Yeah, yeah, that is, but what is the functionality of that? That you need to specify clearly. Okay, you understand the use case and you specify it clearly, then you decide whether to continue all the nodes or you want to stop after getting the location. No, no, it's not multiple answers. It's a different answer. Uh, Different answer, but context is same. Okay. It's a basically a sequential thing. So it's not about exact string matching. It's about a context. Okay, going forward, currently in our company, we are what we are doing. Yeah, we are using LLM. So we need to validate LLM also, right? How accurately it is doing. Okay, how accurately it is doing. So is it consistent or not? Consistency we need to verify. For that, we are writing unit test for that. How consistently that LLM is working. For that, we will pass the question, we will get the response, and that one we will compare. We will compare whether the accuracy of that. We will not see the exact words. We will see the accuracy of that context of that one. We will the same question multiple times, and we will get the, let's say, let's take a total score or something like that. Okay, so let's say if you want to go to the next level, if you, okay, you need at least 100 points. Okay, so stage 2 100 is valid, right? If it is 100, go to stage 2. That's the condition. Sometimes we may get, yeah, you got 100 points, that is also valid, right? Just 100 is fine, you got 100 points is fine, right? Both are equal, both are same, but it is a more descriptive way, whereas that is just a number. These kind of validations we'll do. Okay, that is how we validate. Ready? Yeah, so that is how we will have this LangGraph. Okay, so if you see so this drawing this graph, right, it's not mandatory, but to visualize, it's a kind of documentation. If you remember Fast API, we have a Swagger, right? You guys are remembering Swagger? It's having all the APIs and request response parameters for testing purpose. It's a kind of documentation. This graph is also your agentic AI document, high level document. That's why we are making a graph and will provide to the users, or just for to identify the flow. Where if something goes wrong, where it exactly went wrong, all the stuff we can see here, right? That's why. Okay, so this graph is not related to drawing. This graph is not related to LLM. It's a Python utility. Okay, this is a Python utility, graph is, or you can use any other tool to draw these things. Okay, but what you need to understand is how these things works. Here if you see, right, the code is very less, but you need to understand how this agentic AI systems work, communication between them. This one, graph page. Yeah, so there is a open API with a single line. You can connect, you can draw the picture, but though that API is not working because of rate limiting, all the stuff. Okay, this graph is just for drawing purpose, but this you can you just spend some time on this thing, but not required. Okay, so if you understand, you can draw on a paper, you can draw on a paper and follow the thing and understand, then you can go to this drawing graph thing. Okay, so your basic thing is that you should understand this flow, how we are going to draw that, and how to connect the edges, how to define the nodes, all the stuff. Okay, any more question? Shiva, Anand? Right, right. That is a prompt, right? That is a prompt. Okay. So yeah, that is a simple prompt. Give me INR value. Okay. So give me a, let's say you have a, let's take you have a USD account. Okay, in USD you have a $100, and you will not specify my amount is this one and other stuff. You just say that give me INR, and the flow is like that, or give me GBP, like that. Okay, so if that is one way, and if you take more realistic example is this one. I think I already told you, but anyway we'll go this one. Where is that? Plan a team lunch. This is your goal. So this is the actual scenario for LangGraph. Plan a team lunch. So what it will do, so team lunch, depending upon your name and the things, you will take the results of, make a call to get the your reportees. Okay, so how many team members are there, what are their availability. Okay, and then get the restaurant and get the availability of that, what is the prices, okay, which one is better, which one is nearby. All these things will get the results and will provide you the information. And if you say maybe if it will ask for the confirmation, if you confirm it, that's kind of a conditional based. So here this conditional base, sometimes it could be human intervention. Okay, prompting basically, so these are the information I got, which one you want to go, or this looks cheaper, you want me to book this restaurant, like that it will ask. So if you say yes, and you go to the next flow. Okay, yeah, any questions? Yeah. What do you mean by UI? Tabular form of what? Okay. That UI is obviously interaction with the UI components. How we are going to see? You have a JSON data. So see, one thing you need to. It's everything is a bank. See, if you are talking about data, right? Data is always in a structured way. So mostly we are following JSON, but maybe some other things structured way you need to follow. Or that data, that LangGraph data we are passing to consumers, how they are going to use their wish. Okay, we should always think like that only, data in a structured form. how the consumer is going to use is, we don't bother about that. We are giving a standard structure and take it. Or if you want a different structure, you provide me the details, I'll modify in that way. That is the way. Okay. Okay, then I'll stop here. So maybe so with this thing, majority topics. Yeah. So Langraph mention you can. Sorry. Uh-huh. LangChain, yeah, I already showed, right? Maybe you guys are forgot. Let's see that. See, this is a LangChain. Okay. When you are interacting with any model, normally we use a simple LangChain. Okay, this is the LangChain one. From LangChain, you open chat, and we interact with what is the capital of India. We use this one, right? So this is simple flow. Okay. Whenever you want to interact with LLMs, we need to go for a framework. Okay. So in let's take in our front end API integration, if you want to call a API, you need to have some library, right? Similarly, I forgot in iOS, I did not remember, but in React we need to have a Axios or Fetch. There are different frameworks we used. Okay, whereas in Python, request is a library to make a call, API call. Like that, for LLM interaction, we need to use LangChain. LLM basically it's a generic term, right? But LLM, there are many LLMs, right? So Google is having one, OpenAI is having one, Anthropic is having another one. So for that, LangChain, basically if you want to interact with the OpenAI, like ChatGPT model, you need to use LangChain OpenAI. If it is a Gemini related thing, we need to have, it's a Google one, LangChain _ Google Gen AI is the library, like that. No. So for interacting with the this one, we go for this one, LangChain. That's what integration. You got it? This is a one node. One node is basically interact with the LLM. That is a node. Okay, you got right. Yeah, that maybe let's try it here. Here we're defining this is a node definition, right? This is a node definition. So here I can have another one. Okay, I'll do that. I get a prompt result from Gemini. This could be my node here. So basically this is a state I'm passing here, and here I'll make a call to that method. Right. Connect to Gemini model. Gemini model that will have a LangChain code. This is a LangChain code. Okay, and this result will pass, and that is the state of that node. Basing on that state, whether it will make a conditional check whether if the result is valid, respond back to the customer, or if it is not proper or not expected thing, maybe one more time use another model. Okay, so something like that we can add a logic. These things means which one? This one, right. These are LLM models, yeah. LLMs, maybe you can say LLMs, large language models. See, I'll give one example. Normally we'll say car. Okay, did you find a car? You never find a car, but you will find a car with a brand, right? There is no car. It's not physically existing one. It's a virtual one, right? Car is virtual. Car is having a properties. 4 wheels, steering, maybe 5 seating capacity, that one. Okay, but we have cars of, let's say, Suzuki car, right? Honda car, right? It's a company brand. Like that, LLM is a generic one. LLM is a kind of a car, but OpenAI model is kind of a Honda model. Okay, like that. Google Gemini, it's a Gemini is Google one. It's a brand like that. LLM is generic. No, wait. You used multiple terms here, Corey. Train the model is different. Inserting the data is different. Okay. So nowadays people are not going to train. So that is those days are gone, because we have already LLMs available. You the No, in olden days, those are not. That is also model. That's not a large language model. It's just a model, machine learning model. Okay, that is a machine learning model. That machine learning model trained on specific data. Let's say if you want to identify a face. Okay, that trained on specific faces, like maybe company is having some onboarding photos, maybe trained on that, or maybe training on transactional data. Let's say that the bank is having some data, it trained on that transactional data. Okay, that we will call as a machine learning model. Machine learning model is different, large language model is different. Large language model is trained on a lot of data. It's all kinds of data. It's not specific to one format. Okay, so that's the thing. So nowadays people are not going to machine learning models. Training, that is the results also not good. That's why training is also expensive. You need a lot of data. That's why people are going to LLM, and from that LLM they are using. Existing data is basically RAG based. That example I'll give in the next session. Okay, and inserting data is different. We cannot insert the data into the model. You can fine tune the model. Okay, in that fine tuning, one of the fine tuning model is a RAG based one. Okay, there are different things. So normal fine tuning based means you have a model. Let's say one thing is you expertise in specific topic. Let's say in recruiting process, people will let's say for full stack developer, what people will do is they'll select the people basing on a general knowledge, right? How backend works, how front end works. Basing on that, they will recruit, and after recruiting they will give a specific project, right? That project is specific to that domain, right? That's a kind of training. After recruiting, people train them for 1 week, 2 weeks, 1 month, like that. That is a fine tuning. Okay, that full stack developer is have a basic knowledge, general knowledge, that we will call as LLM. After taking that person, we are training for a specific project. At least they should have some basic domain knowledge, right? We cannot directly ask them to work on that. We need to have some project documents, or train them, or giving some KT kind of thing. That KT or training is called fine tuning. We are fine tuning that person to adjust to the specific project. That fine tuning having a different approaches. Somebody will give KT, or somebody will provide documents. Okay, so that's a different things. So anything can work. So like that thing. So that's why you should compare everything in real-time examples. Okay, LLM is a generic model. If you want to work for your specific task, we need to fine tune with your data. Okay, but we cannot insert. Insert is not the right word to use. Okay, yeah. Okay, then I'll stop here for today. Okay, yeah.